Alright, so we're going to talk about Maclaurin expansion for standard series. Okay, so this lesson is tailored for the A levels, okay, Cambridge exams in Singapore. So during the exams, we actually use the MF26. So what happens is I'm going to just pop over to the MF26 to show you where the formulas for the standard series are. Okay, so for some of you who don't already have a copy of the MF26, what you can do is that you could go on to the internet and look for MF26, okay, A levels or SEAB, doesn't matter, all right, in the internet, and you should be able to find usually within the first result. Okay, so you can see there's the one right at the top right here, www.seab.gov.sg. Okay, and it tells you MF26 SEAB. All right, so I'm going to click on that, and it actually allows us to download a copy, okay, in PDF form of the MF26. So if you don't already have a copy of this, go ahead and download this. Okay, you can just click the download button right here. Okay, and then you can just download this onto your computer or phone. Okay, but what I'm interested in, okay, for the purpose of this lesson is to actually refer to this page right here. Okay, so it's actually the second page on the PDF. Okay, and you will see that we have the binomial expansion, and underneath it says Maclaurin expansion. Okay, so there's a little bit of discussion over here how you should pronounce the word Maclaurin, and some students have reflected to me that it should be Maclaurin. Now, the thing is, I did a check on the internet, all right, about its pronunciation. I realized that both are accepted, but it seems that I have more resources on the web that actually turns out to be calling this Maclaurin. Okay, so I leave it to you. So for me, Maclaurin, both works. Okay, so now what we're gonna do is we're gonna take a screenshot of this. Okay, so we will actually take this and put it onto our whiteboard, and then we'll talk more about these expansions. Okay, but for the purpose of the first half of this lesson, I just want to let you know that these standard series that you're going to use in your exams, okay, are actually available, and this is where you can get it, okay, in your MF26, which will be provided to you during your exams. Alright, so I've pasted the Maclaurin expansion from the MF26 over here on the whiteboard so that we can refer to this easily. So for the later part of this lesson, I'm going to show you how to use these formulas from the MF26 to answer some of the questions that you may get in your exams. All right, so it's best learned through examples. So let's take a look at one, which is no way exhaustive, okay, but we'll look at more different examples and go into the more advanced type of questions that you can see in your exams later on, okay, in other lessons. But for now, let's learn the basics. Now, suppose, let's say you are asked to actually figure out what is the expansion, okay, for e to the power of 2x, okay, and you realize that you actually have the standard expansion for ex itself, okay. So what I've just done is that I've altered the x, okay, and changed it to 2x. Now what happens is that all you need to do is to figure out what has been replaced. So in this case, the x over here, all right, has been replaced with 2x. And in that case, what you do is that you replace all the x, okay, in the standard series provided by your MF26 accordingly, okay. So it's pretty straightforward. So all you need to do in this case for e2x is just going to be 1, okay, there's no x there, and then instead of an x now, we will write 2x instead, okay. Then we'll plus, all right, a 2x bracket square, okay. So do not make the amateur mistake of writing it down as 2x squared, because what you're replacing is x, okay. So in that case, when you have an x squared, you will replace this with 2x. That means that you have 2x squared, okay. So this shouldn't be a problem for most of you, okay, but I thought it's also important to just quickly highlight here. Now we're going to move on to 2x cubed, all right, over 3 factorial. Now it depends on the question. Usually the question will tell you to list the first four terms. In this case, we have the first four terms, or they may ask you to list up to and including the power, let's say x cubed, right? So in this case, we have an x cubed, which is this term right here, okay? So in that case, you can stop and just continue with the dot dot dot. That's what I meant, all right? You can stop with writing down the specific terms. Now, if they want you to write the terms further down the powers, okay, or rather with higher powers, then what you can do is two things. Number one, you can look at the pattern, okay? In this case, you realize that all our x, all right, the x here, the x here, the x square here, the x cube here, right? So you know that in this case, the next one will be 2x to the power 4, okay? And at the same time, we notice that we have 1 factorial, okay, which is not written down, obviously, because it's just over 1, right? And then we have 2 factorial, and then 3 factorial. So it makes sense that the next one is 4 factorial. So that's one of the ways that you can list down more terms, although it is not included in your IMF26, right? You just follow number pattern. Now, there's a little bit of clutter here, so let me just erase all this. The second way is to look at the general formula, which is given right here, okay? So let me just widen this a little bit. Okay, never mind. You get ideas actually right here, okay? The circle was actually blocking the plus, okay? So in that case, this is what you could do. So you could see that you have an x to the power r. So if you needed an x to the power 4, okay, you know that it's over r factorial will give you 4 factorial. So then after that, you can increase your r equals to 5, so on and so forth, okay? So just go to the number of terms that is required, or to the up to the highest power of x that is required by the question, and you stop there, right? So let's say that in this question, they actually want us to list down all the terms, okay, in ascending order, up to and including the term which is x cubed, okay? So in that case, once you're done with this, what you need to do is to simplify it, okay? So don't leave things hanging. So we have 2x. The whole thing squared would be 4x squared over 2 factorial is just 2. And then we have 8x cubed over 3 factorial, which is 6, okay? And then after that, you could simplify this a little bit further and put your fractions in the lowest term. So 4 divided by 2, this gives us 2x squared. And then for this guy, it gives us 4 over 3x cubed, okay? Plus dot dot dot. So in this case, you can end off with this, okay? So this will be your answer. Or for some schools or some students, okay, you may prefer to write it this way: 1 plus 2x plus 2x squared plus 4 over 3x cubed, all right? Then after that, you don't do the plus dot 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 anymore. So this is actually more of a presentation. So you could write up to and including, okay, x cubed term, all right? Okay, so it really depends. Personally, I like the first one, okay? But for some schools, and if you're already used to the second way of presentation, this is perfectly fine too, okay? So there we go. I hope you know where to find your formulas for your standard series, and now you know how to apply those standard series for a particular type of expansion.